So guys from the channel, welcome to another video. Today I'm going to be showing you the protections I made there in my particular converter. So as you can see there is a red LED. This red LED indicates that the voltage is high, and there is this LED here that indicates that the voltage is too low. How am I going to simulate it? I have a switched source, it's connected here on the battery part. I soldered a wire underneath, a positive and negative wire, simulating that it comes from the battery, so in my source it adjusts from 11.1 to 15V practically, so it's within the margin. When I move the source potentiometer, the voltages will change and we will see the high voltage arming and the low voltage arming there. I did not put more LEDs here to show that it is okay, when the voltage is within of the adjustable pattern. Here of this potentiometer, the LED will turn off, to save a little space and money with LED, so it will stay on when the voltage is either too high or too low. So here there are only 3 holes left where I have to put the MOSFET. I did the transistor test and it didn't work well, you know. I'm passing it on to you, it even cuts. I did a test here with a fan but it didn't work, so I'll have to buy a MOSFET to put it here too, right? So here there are 2 holes that I left here. The positive and the negative will enter here from the battery and will go through the protection. From the protection there are 2 more holes here, which are mandatory to go through the MOSFET, so if the voltage is too low, a MOSFET will go cut. If there is a positive and there is not a negative, it will cut the power to this module that will be on the side of the board. Then it will cut the switching and the inverter will turn off. If the battery is not too low, it will cut the other part. Let's assume that it cuts the negative, it will turn off the module too, so the converter will be protected from high voltage and very low voltage so as not to harm the battery. So here are the low voltage adjustment trim pots, and the high voltage one. So I'm going to change the voltage here in my switched power supply, and you'll see there as I increase the voltage, the maximum of the source is 14.87, so the inverter will be cut off, voltage will not pass. I will show you here. I measured with the multimeter the pulse that goes to the MOSFET gate both in low voltage and in high voltage. So I wanted it to work at a maximum of 14.4 volts, so here when the voltage drops I will lower it here in the switching power supply. From 14.4 on it will still be working, from 14.5 as I had told you in the video that it will cut, so I will upload it here to voltage a little, 14.51 he already cut the MOSFET, right? Then turn off the converter, then we'll test the low voltage here. Let's say that the battery here drops, you've been using your inverter for a long time and the battery voltage starts to drop, so let's put the minimum I set here. I set it here to turn off the converter at more or less 11.2, but in reality I'm going to leave it at 10.8. I left it at 11.2 because the minimum of my supply is 11.1 volts, so what happens, for me to be able to show this to you, I had to leave 11.2 that when it goes below 11.1 it cuts, okay? So when the voltage drops, you can see the red LED is off and the yellow LED is also off, so in this period the converter is working normally, which is within the low voltage standard and is also within the high voltage standard, so continuing to lower here the voltage, look, you'll see which voltage you're going to cut. So showing you here, as it blinks like this, look, it doesn't keep pulsing the MOSFET gate, understand? So it doesn't mean that the inverter will keep turning on so it can burn the MOSFET. I measured it with the multimeter with another protection LED too, and it keeps flashing like this because the non-inverting input with the inverting input is close to being the same voltages, so it stays that way, but it doesn't mean it will burn the converter. So, going down here, look, at about 11.2 I want you to turn off the inverter. So here guys you can see that he was ill-adjusted, he started to cut when the tension was more or less there in his. Let me raise the tension again to confirm. Allah started to cut the tension when I was close to 11.6V or 11.5, he started to make the cut when the voltage was at 11.5 and to adjust to 11.2 it's simple, just take the potentiometer here. I'll try to do it with one hand that I'm holding the lavalier microphone. So here you just lower it clockwise and you will adjust to the voltage you want. Here it is already flashing and it stopped. What I adjusted in the low voltage potentiometer to 11.5, the inverter will be working, so I'll lower it a little more so we can see the voltage it will cut. Allah started to cut at 11.3. I'll lower it a little more to cut at 11.2. I'm showing it here live for you, now it's off, right? So I'm going to lower the voltage a little more here, at 11.1 volts it already cuts the voltage, so it's going to be right by this base that I'll leave our converter, 11.1 volts it already cut. Now I will show you here the pulse that goes to the gate of the MOSFETs, the negative of the multimeter is in the negative of the source. And the positive pointer is what I'm going to show you the voltage on the multimeter. So you can see here is a 10K resistor with a gate resistor, this one would be the MOSFET that goes there to the low battery. Now I'm going to show you the voltage that is going to the gate of the MOSFET. So you looking there, this is the negative voltage that goes to the gate of the MOSFET, 1.78 volts. This is the voltage that disables the MOSFET, right? So at this moment here it is sending a negative pulse to the gate and this one is cutting the power supply to the module, and now we are repairing here these two resistors are from the gate and the other one is from the LED, so putting it here on the gate of the other MOSFET, you can see that it is sending 8 volts to the gate of the other MOSFET. So what happens, since it is below the high voltage, I set the potentiometer to 14.5, so as it is below this voltage it will release a positive pulse to the MOSFET allowing this normal power supply, so when I increase that voltage I will measure it for you here and you will see that this voltage will change, it will send a negative pulse to the MOSFET gate, so I will increase the voltage at the source when the LED red light up I measure here with the multimeter for you. So now I'm going to raise the voltage here, the low battery LED has obviously gone out and I'm going to go over the voltage here now. So here, beauty, here it is already at high voltage and we will see here the voltage that sent negative to the MOSFET gate, so with high voltage it would also cut the other MOSFET, it would disable the voltage for this module that would cut the inverter would shut down, right? So guys, that you leave a lot of like in this video, you help me and I help you. YouTube is not notifying, YouTube doesn't recommend very small channel, so you leaving a support, a like and commenting I can make the low battery protections available and high okay. So the project was very top, next video I will bring it working if God wants, and I will also have to buy MOSFET here also that there are 4 MOSFET, 2 MOSFET for each transformer. It is little more I want to extract to the maximum there about 500 watts beauty guy. So that's it, the project was very top, all automatic, you can put up to 2 coolers in parallel there. So up to 4.4 you can work fine there if you have a solar board or MPPT. By chance your MPPT burns, the voltage rises to 14.6 or 14.8, you will not saturate the transformer winding, because if this voltage exceeds what you set in the potentiometer it will make the cut to protect your converter. So by chance the voltage drops too much it turns off the converter, and if by chance the voltage goes up too much it cuts your converter too, so it's more of a protection there. All you're seeing there was everything I studied, racking my brains, some things went wrong, as you can see, there's a resistor raised because it is part of the test, right, for us to have success in the end. So that's it guys, leave your like, comment there what you think of the video, if you liked the video leave your like, subscribe to the channel, follow the link there below the channel's Instagram, check it out that there's always news, always I'll post news there. So that's it guys, big hug, stay with God and see you next video.